Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have to complete this table, and it's for an account where the interest is compounded continuously. So notice that we have the initial investment and the annual rate is given, and we have to figure out how much time it will take to double that amount, and then what will the balance be after 10 years and after 25 years. So recall first, how do we compute balance when you're investing a certain amount of money and the rate is compounded continuously? And if you recall that the balance, if A is the balance, that can be computed using an exponential function, and is P e to the RT, where P is the initial investment. So this $1,000 that's already given, that is the value of P. And the R, that is the annual rate. So this 12% is our R. And this is actually 0.12. T is time and A is the final balance. All right. So we have some information given, and then we have to compute these three things and then complete the table. So let's start. How much time will it take to double the initial amount? So what do we really need to find here? We need to find time. So what is T? So that the balance A is twice the initial investment. So it's 2P, but P is $1,000. So the balance has to be 2 times 1,000, which is 2,000. All right, so what we need to do is take our equation and plug this information in and then figure out what T is. Okay, so see, A is 2,000, P is 1,000, so right hand side you have 1,000, and then e to the power R is 0.12, and then T. So we have to figure out T from there. Okay, let's divide by 1,000 both sides of the equation first. So you will have 2,000 divided by 1,000, and right hand side the 1,000 will go away, and you will be left with just the exponential function. So left hand side you have 2 is equal to e to the 0.12t. Now how do we compute t from there? You remember we have to apply natural log both sides. So let's do that. So natural log of 2 is equal to natural log of e to the 0.12t. Also recall that natural log and exponential functions, they are inverse to each other, and so they cancel. So right hand side we will only have the expression in the exponent, 0.12t. And now if you divide by 0.12, you can evaluate t from there. So let's pick a calculator and figure out what time will be needed to double the amount. Okay, so let's plug in natural log of 2 divided by 0.12, and that is about 5.78. So about 5.78 years will be needed to double the initial amount. So we know what is the time to double the amount. Now you have to figure out what will be the amount after 10 years. So what does that mean? Okay, so for part 2, we have to figure out the amount, so the final balance, when T is 10 after 10 years. So what do? We take our equation and plug all the information in and figure out the value of A. So A will be equal to, again P is given to be 1000, so 1000. Then e to the power, r is 0.12 and t is 10. And let's use our calculator one more time, figure out what that value will be. So 1000 e to the power, see 0.12 times 10 is 1.2, so you can use that, and we have about 3320.12. So come back here, amount after 10 years will be this much. Moving on to complete the table, the last thing we have to figure out is the amount after 25 years. It's the exact same thing as part 2, except here the time will be 25. So what is A when t is 25? That's what we have to figure out. We do the exact same thing. We take our equation and we plug in the value of t, p, and r. So A is 1000 e to the power 0.12 times 25. And use the calculator one more time. And the amount is approximately 20085.54. So after 25 years, the balance will be about this much. So we have completed the table for this account where the interest is compounded continuously. Thank you.